Okay, on this last one, we are inscribing a triangle on this circle that's on the left. That means we're going to draw a triangle, just any old random triangle, doesn't matter what it is, inside here, and use the triangle to construct the center of a circle. So this is kind of a useful property of those points of concurrency. If I have a circle, and that circle is just drawn, how is it that I'm supposed to just figure out where the center of that circle is without just eyeballing it to get the exact location of it? So if I draw a circle and I put a triangle on the inside, I inscribe it with a triangle. The triangle is inscribed. However, the circle goes around the outside, so the circle is circumscribed, and the center of that circle is the circumcircle, or the circumcenter. And what segments, what special segments give us the circumcenter? Perpendicular bisectors. Okay, that's what we'll do on the one that's on the left-hand side here. On the right-hand side, circumscribe a triangle about the circle that's on the right and use the triangle to construct the center of the circle. So these are basically the same exact circle. So when we're done, if we wanted to copy it on a patty paper, we should be able to put one on top of the other one and our center point exactly the same. So this time, if I start with my circle and then I draw my triangle on the outside, sure, the triangle is circumscribing my circle, but the circle itself is inscribed within the triangle. That is the incenter. And how do you get the incenter? Angle bisectors. Okay, so let's try that on the one that's over here on the left, that we are going to draw a triangle and then use perpendicular bisectors. And perpendicular bisectors, if you will recall, that is the two-tailed fish, in order to find the circumcenter and the center of that circle. So straight edge, any random triangle inside here. Okay. Yep. That's the tough part, right? So on that one, it's going to be us doing a little bit of eyeballing. Okay. So I'm just going to perpendicularly bisect the bottom one that's down here. Just pick any compass setting as long as it's bigger than half, and we're going to draw half a circle on one vertex, and the same exact compass setting from the other side. Poke some little holes in here so it's easier to line up my ruler with it. All right, technical difficulties with my lead. Come on, lead. I still have some. There we go. All right. Now, do I need the whole entire line for this, or do I just need the midpoint? Wrong. I need the whole entire line because I need to see where the perpendicular bisectors intersect, which is the circumcenter. Okay, here we go. Okay, so there's one of them. And now all I have to do is one more. I don't have to do all three of them because the third one is just going to hit exactly where the other one did. Okay. So I'm just going to use the exact same compass setting that I did before, and you can see that there's one arc already made for me. And then say from this top point, there's another one. There's another two-tailed fish. I'll poke some holes here. Okay. All right, so this point here should be the circumcenter. I'll label it with a C. The circumcenter. And if I were to set my compass from point C to the edge of the circle, it should hit all of my points. It should be equidistant to all of my points. Okay, so there's that side of it. And now let's go over here to the second one. What we're saying is we're going to construct our sides this time on the outside. The sides must be tangent to the circle, and that's the tough part, is to make your sides exactly tangent. So let's say that I just draw in one of my sides. My suggestion is to put your pencil actually on the circle, and then you can put your ruler up against it and just make yourself a line. You have no idea how long this thing has got to be. All right, and then I'm going to pick another point on my circle to do exactly the same thing. And hopefully I have enough room. Okay, so to make sure that I have enough room, I'm going to use just pick an endpoint that's out here and then try to find a tangent line. That looks like that should do it. Okay, so now I've constructed the sides of my triangle, so my triangle circumscribes my circle, but the circle itself is inscribed within the triangle. Inscribed within. And now we need to do the angle bisectors. The angle bisector construction is the sad, dead cyclops. And just like before, we only have to do two of them because where they meet, the third one should meet there as well. So, pick a compass setting. Let's bisect, say this left bottom angle. Put the point in the vertex, make an arc that intersects both sides of this. I'm going to go ahead and do it over here on the right-hand side one because I'm going to have to anyway. All right, now I can use the same compass setting. This is not an obtuse angle. And put the point of my compass in the top intersection points. Here's half of that dead guy's eye. Do the same thing on the bottom. So here's the dead guy's eye for the one that's on the left, and we'll shoot him in the eye in just a second. And then let's do the same thing over here on the one on the right. Okay, I'm going to poke some holes here. All right, there's one angle bisector. And there's the other one. The point intersection here must be the incenter. The incenter special property is that it's equidistant to the sides of that triangle, and that distance should be measured perpendicularly. And if I set my compass setting to the radius of the circle from I to the outside of the circle, like right there, it should hit exactly where we made the tangent line in order to construct our circle. So it should hit right there, and then finally it should hit out here. And there we got the center of our circle. And as a matter of fact, when we get to this point where we study this, the most efficient way to make the center of the circle is the one that's on the left. And as a matter of fact, you don't actually even have to make it a triangle. You can leave off one of these sides and just work with two of them because that's all we really needed. Time to go? Okay, so for real then, this time, construction part of the test. Hey, you have a dice. A die. 2 dice. A die. Well, you didn't like the pencil thing that we did? We did the pencil thing in here, didn't we? Yeah, I did. That's rigged.